morning, everybody. Today we are going to discuss the topic gravitation, or simply the gravity. What is gravitation? What are its applications and its effects? So let's talk about that. Simply, gravitation is the force of attraction that acts between all the matters in the universe, or it is the force that binds us towards the Earth's surface. That's simply gravitation. And let's talk about the story. I think all of you might have heard about the famous story of Newton and his apple. Once Newton was sitting under the apple tree, and an apple fell upon his head. Then he just thought like, why this apple falls down? By all the objects, if I drop this pen from, it also falls down. Like this, all the objects are always falling down. They are not going upwards, or they don't just fly. Why all the objects are always falling down? The answer is gravitation, or the gravitational force. There is a force that attracts every object towards the center of Earth. That's the reason behind it. So Newton derived a law, namely universal law of gravitation, for the to find this force. Let's write the equations. So consider two bodies. Name of the first body is A and the second body is B. The mass of first body is capital M and small body is small. The distance between the centers is small d. So as I told you earlier, gravitation is an attractive force that acts between two bodies. So here this force, gravitational force, is directly proportional to the product of the masses of two bodies. Product means multiplication. So mass of first body and the mass of multiplied by the second mass of second body. This force is directly proportional to the product of the masses, and this force is inversely proportional to the square of the distance between them. The distance between them is d, so the square is d square. So it is inversely proportional to the square of distance between them. So we have got two equations. When combine these equations, we get it as F proportional to mm by d square. Here a proportionality is present. So to remove this, we have to add a constant. The constant is G. G is gravitational constant. Its value is 6.67 into 10 raised to minus 11 Newton meter square by kilogram square. So we are removing the proportionality, and to bring up the equal sign, we have added the constant G. So this is the equation of gravitational force. F is equal to G into mm by d square. G is the gravitational constant, and mm is the product of the mass of two bodies, and the d square is the square of distance between. So universal law of gravitation states that the gravitational force directly proportional to the product of the masses and inversely proportional to the square of the distance. Two more points I would like to add is, the same gravitational force is the reason behind the rotation of moon around the earth and the rotation of planets around the sun. Okay, that's all about the gravitational force. Then we are moving to the next topic, mass and weight. From the equation it is clear that mass has very much importance in gravitation. So let's see what is the difference between mass and weight. Let's write it as mass and weight. What is mass and what is weight? First of all, let's say that mass is always constant and weight will vary. Let's see how this happens. Mass is the amount of substance, amount of matter. This is the amount of atoms present in an object. And weight is the force that gravity exerts on our body. It's the force gravity exerts on our body or any object. So it is the amount of matter and it is the force that gravity exerts on any object. So mass is a measure of inertia. Mass is the measure of inertia. I hope you all have heard about inertia. Inertia is the tendency to continue in a state of rest or state of motion. It's a measure of inertia. So which means that it will be the same everywhere. Wherever you are in the universe, it will always be the same. But wait, it's the force of gravity exerts on an object. Which means that if we move from Earth to another planet or Earth to Moon, then the value of gravity is different there. So this force will also vary. Here the mass is m and the weight is w. It is a force. What's the equation of force? F is equal to ma. Here it is same here also here, but I think slight difference is here the acceleration is acceleration due to gravity. So we can write it as W is equal to mg. So as the value of g changes, then the weight will also change. That's all about the difference between weight and mass. Thank you.